All right, so here we go. Anyways, we're going to solve radical equations. What does that mean? We're going to solve equations that could have cube roots, square roots, fourth roots, whatever roots. You can do it, you'll be able to solve it. So, what do we need to do this? Well, here's a picture from the book. Step 1, you got to isolate the radical on one side of the equation. Oh, you've got to make sure the radical is all by its little lonesome. Yay! Nope. Step 2, raise each side of the equation to a power equal to the index of the radical to eliminate the radical. And step 3, solve the resulting polynomial equations. Check your answers. Okay, so let's look at some examples, shall we? We shall. Yay! Okay, an example. So here's a problem. Square root of x plus 2 plus 4 is equal to 7. Okay, so step 1 says isolate the square root first, or the radical. So I'm going to try to say get this x plus 2, the square root of x plus 2 by itself, which means I need to subtract 4 from both sides. This is just like solving a normal equation, right? 7 minus 4 is 3, so now I have the square root of x plus 2 equals 3. How do I get rid of a square root? Well, the opposite of a square is, the opposite of a square root is a square. So those two like that would cancel each other out, leaving me just the x plus 2. Now if I'm squaring on one side to get rid of the square root, I need to square on the other side. So 3 squared is 9, and then I can solve what's left, which is the x plus 2, subtract 2, and you get a 7 for an answer. Now, you should check your work, because sometimes you'll be able to find, with radical equations, find an answer, but then when you check it, it doesn't work. It doesn't double check out. And I'll give you an example of that at the end. But here I am checking my work. I'm going to put the 7 back into the original equation. And I should get 7 when I get done with that answer. So 7 plus 2 is 9. Square root of 9 is 3. 3 plus 4 is 7. So 7 equals 7. Checks out. My answer's right. Happy joy. I did all the work right. Yay. Oh, yay. Okay, next question. Let's look at another example. Oh my gosh, what do I do here? Well, again, isolate the square root value. Move the 1 over to the other side. 5 plus 1 is 6. Then again, if it's a square, or I'm sorry, a square root, we square it to get rid of it. That would give me 36 equals x minus 2, and thus I could say add 2 to both sides to get 38. Double check my work. Hear me double checking the work. Plugging it in, solving, getting the same answer. Both sides are equal. Happy joy, it checks out. I did everything right. Yay! Alright, so what happens if I give you something like this? A rational exponent. Oh no! It's the exact same thing, kiddos. It's just the only difference is how do you get rid of the 1/3. Keep in mind, that's like saying cube root. So what's the opposite of a cube root? Cubing it. Or raising it to the 3rd power. Notice here that I'm adding 4 to both sides, then I'm dividing by 2, so I'm getting what's in the parentheses all by its little lonesome. Okay, so now I got to get rid of this 3, or this 1/3, and I can do that by raising to the 3rd power. Because again, that's the same principle as if I had said cube root like this, 6x minus 3, because remember, this right here is the denominator, and then I raise that to the 3rd power to get rid of it, doot, doot, like that. So same thing here. Doot, 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 doot. Okay, so that leaves me with a 6x minus 3, and 2 cubed is 8. Add 3 to both sides, divide by 6, and you get a fraction answer. Oh no, I did something wrong. I must have gotten a fraction answer. But wait, there's more. Let's check it. Wait, I got a fraction answer, and it still works out. Oh my gosh. Look, you could have typed 6 times 11 over 6 minus 3 into the calculator. 6 times 11 over 6 would give you 11. 11 minus 3 is 8. So I'm left with 8. No more fraction. Ha! Okay, so 8 to the 1/3 power is 2. 2 times 2 is 4. 4 minus 4 is 0, which is what I wanted everything to equal to. So yes, I did all my work correct. And yes, I could get a fraction answer. Ha! Anyways, I digress. Let's see here. Here's an alternate method for doing this type of problem. Notice that I'm saying this is a 4th root. The reason why I'm showing you this method is because I've seen this done with, like, especially in pre-cal. They like to do this, or even in calculus, like some higher mathematics. So what we're going to do is we're going to temporarily put a variable in the place of the whole fourth root 2n plus 6. So I'm saying u, and for some reason when you use u a lot on this, u is equal to the fourth root of 2n plus 6. So now if you look at this, this looks like just like a normal two-step equation that you've done before, where you would add 6 and then divide by 3. So you add 6 and divide by 3 and you get u is equal to 2. Okay, now that you got u by itself, you go ahead and put back the fourth root, 2n plus 6 equals 2. Notice how all I've done is put this fourth root of 2n plus 6 in place of the u, which I had put the u in place of that. So I'm just kind of going back. You really don't need to do this. This is just me. I'm just doing this to show you like what maybe somehow some other people might visualize. Anyways, if I raise this to the fourth power, I get rid of that. So I get 2n plus 6 equals 2 to the fourth power, which is 16. Subtract 6, divide by 2, and bada bing, bada boom, there you go. And you get n equals 5. Now again, we could check this. I'm not going to check this one right now. But there you go. That's pretty much how you do this. Okay, here's another example. You can see here, this time I just have the z to the 1/2 power. It's nothing else is with it under the parentheses. So I'm going to isolate this. So I'm going to move the 2 over here. I get 4z to the 1/2 power, which is the square root, is equal to negative 2. Divide by 4, and you get z to the 1/2 power is equal to negative 1/2. If you were to square that, because again, 1/2 power is like, say, a square root, and square this, you get z is equal to, that is the worst looking z. Okay, let's try that. Z is equal to positive 1/4. When you square negative, you get a positive. Now, let's check this work. So this is my answer. Check my work, and I put 2 plus 4 raised to the 1/4 power. I'm sorry. 4 times 1/4 raised to the 1/2 power is equal to 0. Well, 1/4 raised to the 1/2 power, which basically means square root, would give me 1/2. 1/2 of 4 is 2, and now I have 2 plus 2, which is 4, which doesn't equal 0. So that does not work. You can double check your work. Everything is right, but what happens here is, because, and focus on that negative, is that this one is one of those where like you have to double check your work, and even though you solved it correctly, there was no answer, so this one is no solution. You did it right, it just that the actual answer doesn't work. So this problem technically would have no solutions, or probably no real solutions. But that's it. There you go. So that's keeping it kind of simple. I'm not going to go too far into this. We could look at inequalities, but I'm really not. And I could try to make it more difficult, but I don't really need to. So that's it for today. Thank you so much for your time, and I do hope you enjoyed the lesson, and hope that this will be something that y'all understand really well. Thank you so much. Y'all take care.